Alright, so for graph interpretations, you're going to get a problem that looks just like this one here. And when it asks for a degree, you basically just take this number, and if that's an even or an odd number, that's what you circle. So 3 is an odd number, so we circle odd. And then for the leading coefficient, it's going to be the number that's in front of the x to the highest power. And since there's no number here, we're just going to act like there's an invisible 1 there, and 1 is a positive number. It's not a negative 1 or a negative 3. And then using graph interpretation for here, because the graph is odd and positive, when x is negative infinity, then y is negative infinity, and when x is positive infinity, y is positive infinity. And to find your x-intercepts is what you would use when you would solve this problem for its solutions, and the two solutions that you solve for are the two x-intercepts. And then how many turning points there are is you take this number right here and you subtract 1, and that equals 2, and that's how many turning points there are. Using the double distribute method, you're going to get an equation that looks like this, and since this equation is to the third power, we're just going to write out this 3 times. So once you have that out 3 times, you're going to have to distribute these two, and you're going to get a long equation like this, and then you distribute the third one to this equation. Then what you're going to have to do is you're going to have to group the common ones, and you're going to have to factor them out. So all the ones with the common signs, you can add together so that you can get your final answer. And make sure that you always put the x before the y, and because that's in alphabetical order. So your final answer would look like this, because you would eliminate, you would add all these together. So like 2yx squared would add with this 2yx squared and that 2yx squared to lower the amount of numbers used. And then the same thing, you basically do the same thing using Pascal's triangle. Well, you're going to get the same answer, but instead of distributing it out and it getting really long and confusing, it's only going to be in 3 lines. So this 3 right here means that you're going to be in row 3, which is 1, 3, 3, 1. So you write out 1, 3, 3, 1, and then you take the first similar number that you have here, and you're going to put that to the third power. So you have x to the third, x to the second, x to the first, x to the 0. And anything to the 0 power equals 1. And what you're going to do with the 2y's, you're going to do the same, but you're going to do it going from right to left. So you're going to do 2y to the third, 2y to the second, 2y to the first, and 2y to the 0. And you're going to add all of these together. And then once you solve, you kind of solve for these, you solve down to find what the true values are, and obviously to the 0 power that equals 1, and you should get the same answer here as you did doing the double distribute method. Alright, so factoring out completely, you're going to get an equation that looks like this, and what you're going to have to do is you're going to have to factor out a common binomial, and right here the 2 is the only thing that goes into each of these numbers. So you can factor out a 2, and then you're left with this. And what we're going to want to do is we're going to want to group these two and group these two so that we can factor out another common monomial from each of those. And then you're left with x to the third, and this 2 just keeps dropping down, but you're left with x to the third minus 27 times x plus 2, because this and this just turn into 1. And then once you get this, it's also the same as x to the third minus 3 to the third. And we're going to use the difference of 2 cubes for that. So then that's the equation that is a minus b times a squared plus 2ab plus b squared. So your equation is going to look like this right here. And this x plus 2 just keeps dropping down along with this 2. So just don't pay attention to them until the equation's finished. And then x squared plus 6x plus 9 is also x plus 3 times x plus 3. And x plus 3 times x plus 3 is also x plus 3 squared. So your final answer is you're going to drop down the 2, and then the x minus 3, and then x plus 3 squared, and then x plus 2. So when you have a problem like this, you're going to want to use synthetic division, because it's asking you if this is a possible solution to this problem. So what we're going to do is you're going to put a 2 right here, and using synthetic division, you draw this box right here, and then you're going to put the numbers that are all right before the x. And since it goes from x to the third to x to the second to x to no x, we can just use those numbers instead of having to use a 0. Because if it would have gone from x to the third to x and then to no x, then there wouldn't have been an x squared, and we would have to substitute a 0 for that. But since it goes in order, we're fine. So you're going to want to use this possible solution, and you're going to put that right here. And then you're going to put 1 for the x third, and then 4 for the 4x squared, and then -3 for the -3x, and -18 for the -18. And then this 1 drops down here, and 2 times 1 equals 2, and then 4 plus 2 equals 6, and then 2 times 6 equals 12, and then -3 plus 12 equals 9, and then 2 times 9 equals 18, and -18 plus 18 equals 0. And when the final answer is 0, that means that yes, f of 2 is a solution, thus x minus 2 is a factor. So you always use the opposite sign than the solution given when you factor. So what happens is this drops down here, and you're going to have x minus 2, and then all these numbers drop down into this equation, and that you set that equal to 0. And then once you have this equation, you can narrow it down to x minus 2 times x plus 3 times x plus 3, and then to find your solutions, you would set these two equal to 0, and you would get 2 and -3, and those are your solutions. And these are the solutions that you used on the other page for your graph, the 2 and the -3 for the x-intercepts.